Hey guys, welcome to Pre-Lab 1. And yes, that was intentional with the phrasing here. I'll explain in a moment. ADA folks who are revisiting this or I guess visiting for the first time since you've already had this, or BDA folks who are coming to this video again, skip to the timestamp prescribed below. If you are BDA and it is Friday, May 7th, then make sure you guys stick around for this first part here, okay? So, unfortunately, I cannot be at school with you all today, so had this video recording set up so that you guys will be ready to go. But yeah, so we're working on Pre-Lab 1, and yes, poop jargon, or Python object-oriented programming, as we put right here. Typically, you just have OOP, or object-oriented programming, but someone in third block made a joke, and we just kind of roll with it, so there's that. If there's anything for you guys to be mindful about, it's that buckle up, because your brain's probably gonna hurt after this. Or the other possibility is you're like intrigued and like, wow, this is actually kind of cool. Most of you probably, however, will need some more time to process, because quite frankly, college kids don't even understand this, I'm not gonna lie. So again, breathe, it's okay, you'll be fine, things will be great. While I will miss being in class and answering questions on the go, which is honestly the best part of teaching in my opinion, the nice thing here is you can always speed up or slow down the video, stop it whenever you need to, and then go from there. If you have further questions, I will have office hours Monday, probably in the afternoon instead of in the morning due to some other SOL problems. And then next class on Wednesday, we will continue to work on this as well. So hold your questions should you have any, but let's get started here. So follow through the setup instructions here real quick. So I guess we might as well start this here. Open JGrasp. We're gonna have a new file. Make sure we click Python, not Java. I made this mistake with my 8 blocks here. And then Pre-Lab 1, and then we're gonna go back to the vocab. So in JGrasp, hopefully you guys have it open. We're gonna go to, actually first thing I'm gonna check here is this whole shenanigans, because apparently some of you guys can't read. So let me explain once again. This right here is sort of the directory folder. It kind of gives you an idea of where you're saving all your files. So recent, or mostly it'll be something like this, where it'll say this PC with a whole bunch of drives here. You may need to actually scroll down here to find the Google Drive file. Mine is called the G drive because I personally changed it. Most of you will have the U drive instead, but just find it where it says Google Drive or Google Drive file stream, whichever is the case. Click on that and then travel to your computer math folder. Now mine's gonna be different because I have a different setup than you all do, but find wherever your computer math folder is. So in this case, I put it in this school year, and then find, just make sure you're at the same directory or folder that has your CMU graphics. In my case, it's under test Python files. I have CMU graphics here. Once you have this set up, this will come into play in a second. When we're saving files, it makes things so much easier. Just the convenience is super nice. So we'll do File, New, Python. Yours might be in Other if you haven't opened a Python file yet, so just keep that in mind. We'll click Python. And the first order of business you always do is save. Never trust autosave, never trust any of that garbage out there, because you never know if it's actually gonna work. So yes, autosave is on, clearly, but always save. So I do Control S or Command S on Mac, or you can just do File and Save or Save As. It doesn't really matter. This is the first time we're saving it, so it really doesn't matter. We'll just do Save As, I guess. And we're gonna call this Pre-Lab 1, lowercase p _1. I'll explain this notation and what we're actually creating later on, but just make sure it's lowercase here and following all conventions there. We don't like putting spaces for coding, so programming in general, so we put the underscore there. So it's save, we're good to go. Let's go back to the instructions here, and perfect. So the vocab part, I'm gonna kind of go through real quick. I already have examples here, so you can read it, but me providing some context helps as well. But what I'm also going to do is I'm going to combine this with what we've been doing with CMU. So creating a rectangle, creating a circle. We've been doing a whole bunch of this stuff. You just haven't realized it, okay? So the first part is the idea of a class. It's a blueprint, it's a set of instructions, it's a recipe on how to build something, how to create something, how to make an entity exist. So the example I give you here is about a car. All the major car producers, right? So you got Toyota, you got Hyundai, which is technically part of Kia, I think. GM, Chevy, all those companies, that they have factories that produce cars, right? Do not mix up the production with the actual car itself. They will produce cars. They have instructions or a blueprint on how to build the car, but that is not the same thing as the car itself. If I told you all, hey, I'm gonna bring cookies next class, but then I end up just distributing pieces of paper with instructions on how to make the cookie, you'd probably be upset. I'm not wrong. I said I was going to give you cookies, just I didn't tell you how I was going to give it to them. But the idea is the fact that the blueprint or the recipe for the cookies is not the cookie itself, right? I can give you a recipe on how to make it, but you have to actually make it for it to, exist. So that's the idea of a class. I'll swing back around and include how this all ties in with rectangles and circles and all this stuff. Object is simply an entity or an existing item, or as we say, an instance of a class. So the class is a blueprint, right? It's how you make an object effectively. When you make the object, it's called an instance. These are two synonymous words. Again, a lot of jargon. Get used to it. It takes time. So in this case, we could say like a 2020 Honda Civic, literally in your driveway. If you wish you had one, cool. If not, then it is, whatever it is, right? But that would be the object of the car class. So there's a car class that explains how to build cars, and then a object from the class could be a 2020 Honda Civic that sits in your driveway. So just an example out there. Let's see here. Every object has two components. They have methods and they have fields. So a method, think of it as it's just a behavioral thing it can do. So all cars, or I guess in this case the Honda Civic, you can go forward, it can go backward, it can turn left, turn right, honk, window wipers will do the thing, turn on blinkers. Thankfully it's not a BMW, so we actually have that capability for a method. But these are just some examples we could do here. So usually things that the object will do. A quick little caveat, this also will, again, take some time to get used to, but we've actually been doing methods pretty often, you just haven't realized it. Every single method we have is a function. So if you think of certain methods we have so far, you can think of like in the group object or the group class, you can do like the group name dot add, group name dot clear, group name dot remove. You have app dot stop, app dot pause. They all have something similar in that they always have the open parentheses, close parentheses. So I can just quickly type it in right here, like app dot stop. Notice it's in open parentheses and then closing parentheses, right? App dot pause, right? If it's a group, you could say whatever the group is called. Let's just call it G. G dot clear means remove all shapes from it. And they all the same thing. They have a set of parentheses, or a parenthesis, technically speaking, in this case. It's actions, and this kind of makes sense. Typically, methods are tied to actions. That being said, though, those are also functions because there's code in the background that's being repeated, or you're asking it to do a certain set of code, and that's what functions are. It's just methods are special functions. They are functions tied to an object. It's what an object will do. So something to keep in mind. Last but not least, a field are the characteristics or the attributes of the object itself. So for the Honda Civic we have, as an example, you got the paint color, you got the engine type, number of cylinders, body type, wheel size, so on and so forth. I'm trying to think if there's anything else we need to tie in. Oh, the reason why fields and methods are sometimes a bit, like the lines are blurred, is that usually when you make a method, what you're really doing is you're modifying its field. So like you can have a method that, like for the car example in this case, it could be like paint car, which means you're changing the color of the car, which means you're modifying the paint color attribute. So they're usually tied hand in hand, but they don't always have to be. We'll go through cases later where it doesn't, but just to throw out some ideas here. Okay, so again, class, object, and then the object has a method and a field, or methods and fields. To tie it in with what we're doing in our CMU course, so let's just do a couple examples here. So we'll say, just give it really basic, r equals rectangle 200, 200, 50, 100. So nice rectangle starting at 200, 200 in terms of the top left, and then a width of 50 and a height of 100. We're going to say that this r is the object of the rectangle class. And it's clear because typically speaking, classes are capitalized. It's almost like a dead giveaway. If it's capitalized with like parentheses, you're calling upon the class itself. And this r represents the object. So just as some notes here, we're going to say r is the object from the rectangle class. Also, I apologize for my keyboard. It is what it is. It's going to be loud the entire time, so just keep it in mind. In terms of the object, right, we have different let's start with methods, right? We could do r dot to front, we could do r dot to back. It's doing something to the object called r in this case. And again, typically this is probably just dealing with the ordering on the screen of what shows up first, what shows up last, so on and so forth. And then in terms of fields that you can modify, you can say r.centerx. That is the center x of the object itself. r.opacity, changing how translucent, yeah, or how opaque, I guess that's a better way to go about it. Now, typically speaking, you would have in like a robot case, if we consider this like a robot, you would have something like r.move. We can make that at some point in time. But the thing is, we already kind of do that with the attribute here, center x. We just say plus equals 1, and in the onStep function, it'll move, right? So it's just different ways to go about it in different setups. But for things like Carol the robot, or like other cases where you're using a robot on the screen, this is like other coding like classes or online curriculums that do this for you. But just a heads up there, okay? So now that we tied this all in together, let's see. I'm going to skip past these last three. I definitely skipped them in class for A-Day just because these take a while. Okay, module maybe not, but like constructor itself definitely take a while to get used to. And I kind of had to show you it all first before I explain these things because in isolation, they don't really make sense. So let's go ahead and make the code we need to make here. So for Prelab 1, what we're going to do is we're going to make sure we can import from CMU graphics, import the star, which means we're going to import. So if I click the CMU graphics, there's a whole bunch of other Python files here. The star just means import all these other Python files into where my workspace here is. Okay, so go back to directory. I'm just going to run it just to make sure it works and there's no other issues. This should at least show up an empty window because when you import it, that'll be the default state. So far, so good. And then, oh, sorry, not in the console. Okay, so then from here, we're going to go ahead and we're going to wait. So our objective for today is to create a square class. And realistically, a square really is just a rectangle. But what I want specifically are two things. One, I want to build basically a rectangle that has the same width and height, but that I don't have to type like the same number twice. And then the second thing is I want to make it so that when I have the point, the first two numbers, say it's like 200, 200, I want the center of that rectangle to be at the center at 200, 200. So here's how we go about it. We're gonna make a new file. So file, new, Python, or I'm just gonna do Control N and then do Python. And then we're gonna have a separate file here. Zoom in a little bit so you guys can see what's going on here. And I'm gonna save this, Control S. We're gonna call this the square Python file. Again, don't need to worry about putting .py because it's already done by default. So save, and there we go. Couple things to notice here. Left-hand side, it updates hopefully to show you the files you currently have. Notice that square is underlined. Notice that this square is also underlined. That's because currently I am in the square file. If I click over here to Prelab 1, oh wow, it underlines that one. So this is also really nice to show really quickly which file am I currently in. You can try double-clicking square.py, but all it's going to do is like, hey, you already have it open. Just go here. So down here is to move the tabs around. You can also drag the tabs and reorder them. Personally, I like to have the main file on the left-hand side and going on from there. And you'll see there's a star. Okay, right around here where the X would be, there's a star or an asterisk, and that usually indicates that you have not saved the file there. When you save the file, Control S, it's going to remove the star, and you're good to go. Okay, so in the square file, we're gonna do actually I'm just gonna do this. I'm gonna copy all this because it's pretty much the same thing. A square is just a rectangle. So just make sure we're gonna start from that. And then we're gonna do the first thing. We need to make a class. We need to make the square class. The instructions for making the square. So square, notice that I capitalized it, and that's because classes are capitalized, but the file name itself, this part, square.py, prelab_1-.py, these are what we call modules. So if you go back to the vocab list here, you'll see that that's one of them. Modules are just files with classes and methods and attributes. So a little confusing, at least for Python. Java, you don't have this problem, but Java's got other problems that you gotta worry about. So those of you guys taking AP Comp Sci, you'll deal with those next year. Okay, class square. All right, let's go ahead and define this class. So I'm gonna indent with 3 spaces, or some of you guys being lazy, you'll just do tab, but it is what it is. And we're gonna have to create the instructions on how to make the square. So remember, the class is the blueprint, and then we can create the square object, but what I need is some way that tells me how do I actually create the square. The way we do it is something called the dunder init method. The other way to think about it is a constructor, so I'll put it right here. So we'll say in comments what's called the constructor or the dunder init. So it looks, oops, it's a daisy. Spell it like this, dunder init, and that's short for double underline initialization. I'll come back to this later, but the way we go about it is we do 2 underscores followed by the word init and then 2 underscores after that. The constructor simply is a special method in the square class, or any class in general, that allows you to actually create the square. This is what we're going to have to do in order to call it. So back over here in Prelab 1, when we called the rectangle from the rectangle class, the rectangle class has a constructor or a dunder init method that describes how it's going to work. So the way this works is you need to pass self. I'll explain this later as well. But keep in mind, when we go back to Prelab 1, We're trying to say, hey, I want to make an object, let's call it box1, and I want to make it a square so that when I type this in, it's going to put it at 200, 200. The center of the square will be at 200, 200. And then its size or length and width should be 50. This is what we want. This is kind of like the goal, right? I'm going to comment this out because this will not work yet. We want it so that it goes from 200, 200, 50. Center X, center Y, and then like maybe it's like size, right? So that's nice. So that means with the parameters, we could say center X, center Y, and size. Real quick, I know that, all right, let me put a colon at the end before I continue here. I know that there were some questions like, why are we having two separate files here? And I probably should have said that before. You can combine these into one. The reason why I typically like to separate them, and depending on the context, other programmers too, is that if you make a separate class for the square, or I guess a separate module for the square, what you can now do is say like, hey, maybe in lab 2, I don't know if we get to lab 3, but like in lab 2, you want to use the square again. If you put the square class in the pre-lab 1 class, or module, I should say, I mean, it's doable. You can still import the square class, but it's nice to have these separated so that you at least have like, oh, like I can actually use this module later on. Now, the best thing that we should really do is we should call this module other shapes and then include not just the square class here, but also have other classes. Like say you want to make a triangle class, you'd be like class triangle, and boom, explain how the triangle class works. That's a great way to go about this. But the whole essence is right now, to keep it simple, you want to make sure if you ever want to use the square class again in another file in the same folder, you can create the other file and import the square class there directly, and bam, there you go. You have a lot of flexibility in how to use it. So just one of the examples there. Going back to this, the next part, it's going to be a little bit of voodoo magic. Okay, so hang tight, hang tight. So we got to do a couple of the basics here, and I say basics because I know how this works, but obviously you guys don't, so we'll get you guys up to speed in a minute here. But go and just type this in. And then last but not least, self.size equals size. Again, I will swing back around because again, this doesn't really make sense without context, which I'll give later on. But the problem right now we're having is that we said a square really is just a special rectangle. Well, where the heck is a rectangle, Mr. Park? We're going to cheese it a little bit by doing something like this. We're going to call the rectangle. And then this is the part where you would have to actually modify the rectangle's coordinates to match like what you want to do. So just trust me when I say this works. I may go through the logic behind this later, but it's going to be this center X minus size over 2. Then the Y value is center Y minus size over 2. And it's just length and width or size and size because they're the same. Move it back a little bit. Let me zoom out so you guys can see that last part. Perfect. There we go. Pause here if you need to. I'm going to move on because we're basically done. We've created the square, or rather, should I say, we've had the instructions to create the square. So I'm going to save it, move back over here, and we're just going to try it and see what happens. Now, I'm pretty sure I messed something up here, so let's take a look. Yep, so nothing shows up, which means if I look at my error, and it's actually good because if we don't ever have any errors, and like maybe we're actually doing things a little too well. So we say in whatever this file is, it unfortunately cuts it off because in my drive there's a space, and so it cuts off anything after space. But we say line 3, there's something wrong with box 1 equals square. It says square is not defined. Perfect. So I made the exact mistake I wanted to. Your code has no clue what square is because yeah, there is a square module in the same sort of directory as this file itself, but you have to specify, hey, I want to make sure I do that. So we're going to have to make sure we import from the square module. From the square module, we're going to import the square class. Technically speaking, we could do the asterisk, which means every class, which there's only one class in there. But for simplicity's sake and just to be concise, say square. So let's go ahead and do that there. Let's double check. And voila, we do have a square that seems to be at the center. If I hold Control, I can see, yeah, it's a 50 by 50 square. And based on the X and Y coordinates, it seems that, you know, they're 50 apart. Okay, cool. So if you want to know how I figured out that formula, center X minus size over 2, the center here is 200, 200. That's where we want it to be. But remember, the rectangle requires the top left. So to get from the center to the top left, I need to go left half of the size and then up half of the size. So going left means go left size divided by 2 because size is the whole thing, not half. And then going up by the entire size divided by 2, or the length or the height, I guess in this case. So that's how I figured out the formula. Again, you guys will have to do this at some other points in time for other shapes, but again, just a nice little trick here. But yeah, that actually worked. Pretty cool. Now, let's specify some things here real quick, like the self keyword, because this is very important. What happens is, let's go ahead and do this. Let's make box 2 so that we at least have some reference point and helps kind of explain the context. We'll do this, 25, run the code. So that means it should pop up down here. Okay. I'm going to skip over to OneNote to kind of explain this part about why we have this self keyword. So let's go to OneNote, and I think this should be good. Okay, so let's go ahead and run through this code sequentially. This is going to be line 1, and I apologize. This is not my laptop, so the handwriting is going to be absolutely atrocious, but bear with me, please. So that's line 1, that's line 2. If you run line 1, we're going to say, hey, we have a square at this 200, and this 50. So let's start with box 1. We can kind of imagine there's going to be literally like a locker or a storage space in memory. That's called, let's put it purple, box 1. And in this box, what's inside of it? What do we say we stored inside of it? We store a square inside of it. Okay, so we say inside here, there's a square. Good to know. So box 1 really is just a square object. Box 1 is an object from the square class. But we have some arguments being passed here. We have a value of 200, a value of 200, we have a value of 50. So what do these actually mean? Well, it says, well, first I need to go to the square class. So what we're going to do is we're going to take a field trip. We're going to jump over to the square class. Here it is. There's the square class. Well, the square class, when someone wants to create the square, I have to run the dunder init method. Dunder init requires the self, which really is just box 1. Box 1 is self in this case. The center x value. Okay, so that means there's some, let's draw some more boxes. There's another box here, and then another box here for the center y, and then a final box here for the size. So that means we have a center x here, center x, sorry for the handwriting, center y, and then size. In this particular case, what's happening is I am passing these arguments over into the parameters. The 200 maps with center x, the second 200 maps with center y, and the 50 maps with the size. So what happens is temporarily, only in this dunder init method, center x is 200, center y is 200, and the size is 50. And then what happens is we take each of these components, the center x, center y, and the size, and we're storing it into self.centerx. Remember, I just told you self really is just the object that you're currently dealing with, so box 1. So what the code will do is it'll replace all the selves with box 1, so on and so forth. So now over back in box 1, we just take the values we just found in this local, these local variables here, and we store it back in here. So what's happening, and I'm going to go ahead and insert this as text instead, if possible. Oh, never mind. Draw. Let's go back to that form. So what's happening is it's going to say that the center x of the box now is actually equal to the center x that we just passed through before. So that's 200, and then center, excuse me, if I can spell, center y is also equal to 200, which is the second one. And then last but not least, size is equal to 50. I should probably lowercase that so that we're good to go. I'll zoom in just so you guys see. We are passing from, and it seems kind of counterintuitive where we're like passing into one class and then the class gives it back to us, but that's pretty much what's happening. Here in like our main class, so to speak, or where we're running our code, it's saying, yo, square class, can you make something for me? Square class is like, I got you, bro. And then it gives it back to us here. So that now we have all the values updated as needed. The reason why this is important is that when we get to line 2, we do the same process. As we travel over into the square class, what happens now, if I can scroll on over here, excuse me. Oh, there we go. If I could scroll on over here. Instead of the self being box 1, it replaces with the current shape at hand, which in this case would be box 2. Self simply just refers to the object currently at hand. Just replace self with that object, dot center x, dot center y, dot size, so on and so forth. Go from there. This is usually pretty nomenclature and pretty normal, just because of the fact that we want to store these localized variables that we just kind of had, and we want to attach them to the shape. So that the next time I actually deal with box 1, if I do box 1 at center x, I can actually get its value. Now, this last part here, self.shape, this is the part where it gets a little interesting, because self.shape is a rectangle itself. So that means if I go back to the code here, let's deal with box 1, strictly speaking. Box 1 dot shape, or if I try to do like box 1 that's center x, say is equal to, let's move it to like 10, right? You would think that, oh, because box 1 is the square, that means box 1 that's center x should move the square to 10. However, if I run the code, you'll notice that the box 1 has not moved at all. And that is because what we need to do is we want to say that, hey, I want the rectangle. Well, if you go back here, the rectangle is represented by this. This is actually the rectangle, and this is why this is a roundabout way to make this work. So this itself is actually the rectangle. So in order to move the box, you have to do something a little A little tedious, but box1.shape.centerx, because this box1.shape is the rectangle, and then rectangle.centerx equals 10. When I run this code, we now get this. It actually moves. Unfortunately, this is the workaround we have to do. We also cannot change the color like this. We can't say fill equals blue because, again, we're transferring or we're taking it and adding it to the rectangle. And unfortunately, due to other circumstances, that it's not going to allow you to do that. But it works for now. And the idea is we're getting used to classes, objects, using their methods. We'll get to creating methods later on, and as well as making their own attributes, but you've already done attributes right here, or the fields. These are the fields of the class right here. Anything with self, dot, whatever, these are what we call the fields. And then as for a method, like we could make one up real quick. I guess we could do like what's a good idea? I guess we could do something like show details, right? Using these, I'm trying to think if we need to return anything. In this case, yeah, we do want to use a self here. And so then we can do something like, I want to make a label that shows the details of the particular shape at the particular time. So I can say something like label, parentheses, like the message is going to be something like, let's say, we can say something like the size of this square is space plus and then string self.size, because that's the size that we're trying to figure out. Location we'll put at the center X of the object, so we'll do self.centerX. Oh, this is actually another reason why we want to do this, because in the dunder init method, or in the constructor, when we pass the centerX value to self.centerX, I can now use this variable and apply here. If I try doing centerX here, it would say error, doesn't know what centerX is, because remember, centerX only exists in the dunder init function. After we're done with constructing it, it no longer exists. So now we want to be able to pass it like so. And self.centerY. I'm going to do one more cheat thing because I know it's going to happen here. It's going to show up at the middle of the box or the square, but it's going to be black. So we want to change the fill to be white instead. So we'll do that. Pause for a second there. And then now save that. If I go over here and I say, hey, box1.show details, like so, I'll run this. We should hopefully see now. I think I'm moved. Oh, wait, hold up. Oh, let's do this first. let's change that. Let's run this, and theoretically, I probably should change another code, but you see the text. You at least see the text. We should probably change the color. Let's do, or we should just make the box bigger. Nah, let's just make the box bigger. It's easy. Let's do 100. Run that code. Okay, never mind. It's really big. 300. There we go. Now you guys see it right here. Yes, the size of the square is 300, matches exactly the argument I threw in the first place. Hopefully this is a decent introduction for the first part here. We will continue this on next class and talk about just what we're supposed to do for the rest of the pre-lab. If you are reading through it, you can kind of see down here in part 2 what we're trying, or what I'm trying to make you guys do. And then we'll also deal with submissions. This is more for me than for you guys, just to check out like, hey, can we actually like make this work? So again, we'll finish this next class, but again, get the jargon in your head because this vocab is going to be very important from this point forward.